commit.
I don't need a clicker. Yeah, I got my laptop.
You can take this and go on set for the questions later. I'll then go that just here.
Can you switch? Yeah. Thank you. Hey, good evening, everyone, and welcome to the Art of Encryption. I hope we'll all learn something together over here because I don't think I know that much about encryption either. So, yeah. My name is Pavitra, and I'll be your speaker today. I'm a data engineer, and I've been working for over a year at Casna, which is part of Mantle Group. To be honest, I guess we are also hiring, so you can totally hit me up on LinkedIn. Yeah. Yeah. So today, for the agenda, I thought we'll cover what is encryption, why we have to do encryption, when do we do it, all the basic questions that you might have about encryption. So what exactly is encryption? Well, it's just a method to transform data into an unreadable format when you're transmitting data from like one place to another. And so the process of doing this is to convert it into an unreadable format and then bring it back into the readable format once it reaches its destination. So why do we do this? Well, before I go into why we have to do this, let me tell you a little story that I read the other day. So it was this little news article that I read where there was this couple who was buying a house in Sydney. God bless them. Who can buy a house in Sydney? But yeah, so they were buying a house in Sydney, and apparently they were talking to their real estate agent back and forth, and he just he was like, okay, I'll send you guys my account details, and you can send me the deposit or whatever. So yeah, they sent the deposit, and they were all excited that they got the house, but turns out they sent the deposit to the wrong account because the message got hacked, and then they got the wrong details, wrong account details, and they just sent it to the wrong person. So they basically lost their whole life savings and didn't even get the house, which is really sad. Yeah. So this is basically why you would do encryption, so that there are no man-in-the-middle attacks. And even if someone does try to read your message in transit or your data in transit, it basically turns out to look like something else. And that's the reason you would want to do encryption. Cool. And when do you have to do encryption? Well, since I'm a data engineer, I'm going to be mostly talking about it from a data engineering perspective. So I work with GCP because it's the best cloud there ever is. And yeah, when I'm working with GCP, and as a data engineer, all I'm doing is migrating data from other clouds, like AWS and stuff, into GCP. And then sometimes we also migrate out of GCP into something else. I don't know why they would do it, but yeah, sometimes that happens. So when I'm doing this migration from other clouds into GCP, I don't have any control over the data at all. So that is when I would do encryption. Because all the data within GCP, when it's at rest or in transit within GCP, is always encrypted by default. So I'm not worried about when data is sitting inside GCP. All I'm worried is when the data is coming into GCP or when it's going out of it. Only because I don't have any control, especially if it's like super confidential, then I would really, really want to encrypt my data. Well, what are the types of encryption? So this is a really cool concept. So the two different types that I have are not exactly exclusive. You can have an overlap between these different types that I mentioned. And they're not, they're like two different ways of classifying encryption methods, I guess. So what is probabilistic encryption? Well, Before I tell you what probabilistic encryption is, again, let me go tell a little story, right? Yeah, so let's say I'm the security detail for the prime minister. And then every day when the prime minister is leaving the building, I'm like, the red room has left the building, or the red room has entered this building. So every day, if a hacker is trying to listen to my conversation, even though the data is encrypted, he's going to keep listening the red room as something that is going to be translated into another word. So if my data is going to have similar patterns, I want the encryption to give it a different ciphertext. So this red room, I want it to be like transformed into a different ciphertext every time we do an encryption. And that is probabilistic encryption. So the same data, when you encrypt it, gives you a different result. And I guess you would use it in like a regular day-to-day exercise when you have data that follows a similar pattern, and you don't want, even if it gets hacked, you don't want the hacker to understand these patterns. So that's when you would use probabilistic encryption, so that you always get like different results for the same patterns. And deterministic. It's obviously the opposite of probabilistic. So in deterministic encryption, you have the exact same result given the same input data. So if you give, and when would you actually use this deterministic? It's not actually super useless or anything like that. It's actually very useful. So when, let's say I got a lot of data migrated into GCP, right? And I want to do some transformations within the data. But like the company does not want the dev and test environments to have the actual data in it. And I can't really transform the data without doing proper joins and stuff. So that's when deterministic encryption would come into use. When I'm trying to join two different tables that have really sensitive PII information, like my date of birth or like, my location data or something like that. So then I would want to encrypt my location data using an encryption key in one table, which gives the same result as when I encrypt it in another table. So that's when I would use deterministic encryption so that my data remains the same, and then I can easily do a join. Yeah, so symmetric encryption. Well, symmetric encryption is basically when me and a recipient who I'm talking to are using the exact same key to encrypt the data. What is a key? A key is basically a really, really long password saved in a file. That's essentially what it is. There's nothing too crazy about what a key is. So when me and my receiver are using the exact same key to encrypt and decrypt the data, that's called symmetric encryption. And asymmetric is the reverse. When me and the receiver have different keys, it's usually a private and a public key. So the data is usually encrypted with the public key and decrypted with the private key. You might wonder why we would do this, right? Like, why not encrypt it with my private key? Well, as you know, as you can understand by the term public key, means it's public. Like, you can share it with anyone. And anyone who has access to your public key can now decrypt the data if you encrypt your data with a private key. Whereas if you encrypt your data with a public key, only you can decrypt the data because you're the only one who has access to your private key. So that's why you would always like encrypt your data with your public key and decrypt it with the private key. Cool. And how would you do encryption? I'd mostly be talking about how to do this in the cloud, because honestly, doing it on your like local laptop is super easy. I actually struggled quite a bit to put together the demo because it's actually really challenging to do this in the cloud. And what gets challenging in the cloud is storing your keys or setting up the environment to make sure the algorithm you're using has an actual base folder that it can access and stuff like that. So that's where it gets a bit challenging to do it in the cloud. So the use case that I am tackling here is, let's say I'm getting data from an external source. The data would usually land in my cloud storage buckets. And as soon as it lands in a cloud storage bucket, I would either use a cloud function or a cloud run to basically get triggered. And once the cloud function or cloud run gets triggered, it decrypts my data and puts it into BigQuery. So that's essentially what I want to do. Yeah, cool. So I have a little demo prepared as well. Let me bring that up. I was warned this would happen. Give me 1 second. Hey, I'm just trying to.
You might just have to escape it. Is that okay if we escape it?
Yep.
There we go.
Oh, I want to actually bring this. Sorry, 1 sec. The terminal. I want to bring this there.
That one there?
Yep. Okay, thank you.
That's it.
That should be okay.
There we go.
Good. Thank you. Yeah, cool. So I have a file that is sitting in the folder that I named very aptly decrypt test because I'm testing a lot of stuff. I thought today we could look at OpenSSL, which is a type of algorithm that you can use to encrypt the data. So there are a bunch of other encryption algorithms, but I decided to pick this because it was honestly very, very easy to like set up and actually do an encryption and decryption. So I have a file, a data file that is sitting inside this decrypt dot test folder. So if you look there, there is just that one file that is sitting there, the data.mp4, and I want to actually like encrypt that file. Oh, you want to make it bigger? Okay. That's better, right? Cool. Yeah, cool. So that is a command that I got literally just off of Google on how to encrypt data using OpenSSL. So that is just an encryption that I'm trying to do on this file. So it basically takes in data.mp4 as the input and gives me data.mp4.encrypt as the output. So then it's going to ask me for my password. So I just created like a random, I went to like a password generator, generated like a really complex password just to make it very secure. Because here we'll just be doing like a symmetric encryption. So the encryption key and the decryption key is going to be the same. That's why I wanted to make sure my password was very secure. So I'm just putting in my password. Cool. So that's basically it. It encrypted my file. And then if you now look at the contents in the folder, it's going to have my encrypted file as well. Cool. Then let me show you the setup I have within Google. So sorry. It's very weird. It doesn't let me like send anything that side as and when I have a window there. Cool. Okay. So this is basically my cloud function. So I have a bunch of buckets set up here. So this is the encryption bucket. So here is where I want to land my files that are encrypted. And And then I have my algorithm, the cloud functions that I've written, where I've written a little neat Python program just to decrypt my files. So as soon as data falls into this bucket, what happens is I have a pub sub sitting here waiting for any notifications to occur on this bucket. So as soon as the pub sub gets notified, it triggers my GDG and decryption cloud function. So once this gets triggered, all it's trying to do is it's trying to get my pub sub message, which is essentially just to like get the data and the information from the bucket, just the file that's landed here. And then all we are doing is we are just decrypting it. We are actually decrypting it locally within the Google console and then writing it back into a bucket. So the bucket that we are going to write to is called the decryption bucket. Yeah. And so the thing is, right, we talked about keys and stuff, and so the main problem with using encryption and decryption in the cloud is actually storing the keys and stuff. So this is the passphrase, which is what I'm using to decrypt my file, the same password that I gave to encrypt the file. So what I did was I actually stored the passphrase here within Secrets Manager. So this is my passphrase that I stored. And how I'm actually referencing that passphrase within the cloud function is using environment variables. So Google has a really neat feature where it can just use secrets as an environment variable and expose it within your code. So you can just use it like a regular environment variable. That's honestly the best way to do this decryption and like save any keys that you might have. So just going to upload data into my bucket. Upload files. The data.mp4. Yep, it's successfully uploaded. Then you can look at the logs to see what is happening here. Nice, we got a 4 of 4. That's awesome. Cool. I think that was a false 4 of 4. Let's see in my decryption bucket what happened. I have my data.mp4. Let's see if it's properly decrypted. Thank you. Yes, this was a very high effort meme. Yeah. Cool. That was actually it. Did you have any questions for me at all? Except to ask me to stop this, I guess. That would be a good thing to ask. Yep.
Any questions? Really nice. I think that's even better. I guess, yeah, we could go on.
Good. Thank you so much.
Thanks.